Looking at the homework that is on page 228, number 1. In number 1, a 2.1 meter rope is attached to a tire overhanging a tree limb. The girl swings on it, has a tangential speed of 2.5 meters per second. Find the magnitude of centripetal force. Oh, tell us that it is 88 newtons. What is the mass of the girl? Well, we need to get the equation up here on the screen. So, centripetal force is equal to mass times Vt squared, and we're going to divide that by the radius. Now, you go up here real quick, make this a squared, and make that a subscript. No, that's not what I want to do. Make this a little subscript here, and we're ready to cook. Okay. There we go. Okay. Now, they give us a good number of things here. They give us the radius of 2.1 meters. So let's see here. Grab this. 2.1 meters is our radius. They give us a nice little tangential velocity, which I guess it's convenient that I have an extra 2 there. That gets squared. They give us the, grab it, 88 newtons. That is the force right there. So highlight that, toss it in right there, and just grab that right there, and we are cooking with gas. Now here's the thing, our variable in this problem, they want to know what the mass of the child is, so put mass in. So in order to solve this, we're going to take our 88, we're going to multiply the 2.1 over, and then we have to square this and divide it over. Square that and divide it over, and then we'll pull out our calculator. High tech on here. Let's see, 2.1 times 88. In case you don't have this done on your calculator, you should probably be calculating it right now. Divided by, enter. And according to my calculations, I have an answer of 29.6. We shall say, and that is what the book says, 29.6. If you have questions on it, talk amongst yourselves. Someone should help you out with that. Figure out what you might have done wrong. You may have forgotten to square it. That'd be highly common. Alright, well, let's move forward to number 2. In number 2, a bicyclist is riding at a tangential speed of 13.2 meters per second around a circular track. The magnitude of centripetal force is 377 newtons. The combined mass of the rider and the bike is 86.5 kilograms. What is the track's radius? So in this case, we got all the stuff on top here, but we do not have the radius. So let's see here. Now there we go, 377 here. Again with the equal sign. Always helpful to have an equal sign. I got a mass. And we got a tangential velocity, which of course is getting squared, and we are again having a division sign in here, divided by our radius. So there's your setup. To solve it, I'm going to multiply the radius over, I'm going to divide by the force, and it's time for my calculator. Pull up our high-tech calculator. Let's see, 86.5 times 13.2. No, I didn't square it, so I'm just going to multiply it by it again. So times 13.2. 13.2, I hit the wrong button there. Equals that. I got like 15,000 right now, and now I'm going to divide by my 377. And according to my calculator, it says 39.978, well, 40. 40 is the radius, and the book agrees with 40 meters for the radius. Alright. Again, if you have questions, talk amongst yourselves. Someone in the room should be able to help you out if you have a question. Just kind of moving this stuff out of the way so that we may continue with what we're doing. Okay, time for 3. Number 3. Now this time we don't have centripetal force. So in this problem, a dog sits on a merry-go-round. Now that's just insane. Who'd put their dog in a merry-go-round unless they're just mean people? But anyway, a dog sits on a merry-go-round 1.5 meters from the center of the merry-go-round. It revolves at a tangential speed of 1.8 meters per second. If the dog's mass is 18.5 kilograms, what is the magnitude of centripetal force on the dog? So we're given all those stats over here. We're given all this stuff on that side of the equation to kind of make it a little easier, honestly. So there's that here. Centripetal force goes there, and then just all these guys just kind of come over here and do their work. 1.5 meters is our radius. 1.5 kilograms is our mass. 1.8 meters per second is our VT. And while I'm doing that, one thing please be ever so cautious of, and that is that so many people will try to look for time in these problems. It's not time, it's tangential velocity. Okay, it's V with the T to label it. Okay, so we got that. Get a little divide sign thrown in. There we go. Now when you're solving this, make it a little easier on yourself. Say, oh, 1.5, 1.5, no problem. So really I just got to take 1.8 squared, 1.8, and I square it. And my calculator is saying 3.24. That is not at all what the book says. What did I do wrong? Oh, I mistyped it. It's 18.5. Well, that'll change it all up, won't it? Why don't you guys tell me I did it wrong? Very disappointed in you. So, very different. Now there's no canceling of anything. Now it's straight up doing the mathematics steps here. Let's try again. 18.5 times 1.8. I'll do that again. 1.8 multiplied again. And I hit enter, and then I'm going to divide by 1.5. And now my calculator agrees with the book. 39.96. Book says 40 newtons. There's our answer. Don't be a dummy like me and put stuff down wrong. Okay? Questions? Remember, you can pause the recording if you need to. Okay. Number 4. Now, number 4 gets a little goofy here. We've got a lot of stuff going on for number 4. Get all that junk out of the way. I'm going to need a squared. I'm going to need an equals. I'm going to need a divide. Okay. Number 4, we want to know the tangential velocity. So VT is going here, and they give us this car on a track, and that's fine and all. They give us the mass of the car. They give us the force being exerted on the car that causes it to go in a circle. And they give us this, 3.25 kilometers. I put an exclamation point on purpose because, number 1, it's kilometers. We do not do calculations in kilometers. So very first thing to do is just to change that into meters. So 3.25 kilometers is 3,000 kilometers, right? 3,250 meters. That's cool, except it's not a radius, it's a circumference. So you got to figure out how to get your radius out of that. I'll give you a second to think about that. Go ahead, look in your planner, look in your math book, whatever you got to do. We're looking for a way to get the radius out of circumference here. I'm waiting. Okay, so hopefully by now you figured out the circumference is equal to pi times diameter, or 2 pi r. So that equals 2 times pi times r. So we got to divide this by 2 pi. By 2 pi. Do I have a pi button on this calculator? I don't even know if I have a pi button. I don't have a pi button. I don't care. So I'm going to divide by 2 pi. So I'm going to take my 3,250. I'm going to divide it by 2. And I'm going to divide it by 3.14 and be very content with that. Enter. That gives me a radius of 517.5 meters. 517.5 meters is now my radius. So then I stick that right over here, throw my divide sign in, thusly, right? Dividing by that. Gotta do a little math. So my radius has to be multiplied over. My mass has to be divided over to leave VT squared alone. We will have to square root when we're done. So let's get that calculator back up. Let's see. 517.5. I'm going to multiply that by my 2140. Enter. I'm going to divide by my 905. Enter. And I've got 1223.7 there. That equals VT squared, so I got to square root it. So put that to the 0.5 power. And I'm getting 34.98, so 35. And I turn the page, so I don't know if I have the right answer in front of me or not. 35 is what the book says. 35 is what I found. So that's the centripetal force homework. Again, if you have questions, ask your neighbor, ask someone in class who gets it, and when I get back, ask me. Okay, very good.